Okay, so in this lecture we will be discussing the topics described in the first 5 sections of Chapter 1, which is concerned with basic concepts about matter. So we'll go through and explore a definition of chemistry. We'll talk about the 3 most common states of matter, properties of matter, changes that matter may undergo, and the division of matter into 2 categories: substances and mixtures. So if you haven't already, please, as soon as you can, read chapter 1. It's 20 pages long, and these are the first 5 sections, and we will be covering the next 5 sections in Wednesday's class. So the first question that we have to think about is, what is chemistry? So for many of you, you would say that chemistry is boring. Some of you may have the impression that it's very difficult. Some of you may already have a strong dislike for chemistry. Some of you may be taking chemistry for the second, or perhaps the third, or maybe even the 4th time. But more scientifically, more precisely, we can define chemistry as the scientific study of matter, its properties, and transformations. So we're going to explore each of those 4 words there that I have in bold and spend a little bit of time pondering what we mean exactly by those words. So what do we mean by scientific study? So it's interesting to think about popular conceptions of what science is. So many people might say that science is something dangerous. Something might say that it's something that odd people do. Generally, these people wear white coats. They have crazy hairdos and sort of, questionable hygiene, perhaps. So dangerous, it leads to nuclear war. It leads to dangerous weapons that no one really quite knows how to control. It leads to technology that rapidly gets out of hand and causes problems for humankind. That it's something that people do locked away in their basement, half crazed, experimenting, Dr. Jekyll and Mr. Hyde style, Frankenstein style, something crazy men in white coats do. These are popular conceptions of what science is about. Of course, many people have negative views of science, not that it's a hard subject to study at college, but more of its role in society is considered to be not a good one. So people think of science as being unethical, and that it is in some way against religion or anti-religious, and even that it may be considered to be the enemy, that it's something that needs to be stopped, that it's there to cause harm. And many of the ethical questions that arise in science are concerned with reproductive technology. So here we have a little bit of cartoon where even the embryos in the petri dish are arguing about when life begins. We have the anti-religious idea. This is a cover from Wired magazine, and you see you have this sort of atom and electronic circuitry sort of mashed together with a crucifix. And then for some people, it's science versus religion. It's a fight. One needs to prove that they are supreme over the other. Of course, many people have positive views of science. It's a source of technology. We all love our computers, our smartphones, our flat screen TVs, our hybrid cars, and so on. For some people, they see it as a solution to global hunger, that the only way that we will deal with the problem of feeding our ever-increasing population is to utilize science. And for some people, they say it's our only hope. The only way that we're going to solve the problems that we are facing is through the use of technology that has been developed by scientific insight. And finally, here is a picture that I like. This is the Ark 1 Lifeboat Foundation. These people are actively proposing that the only hope for humanity is to leave the planet. Now, that might sound a little wacky, but I think it's not so, such an extreme view, and indeed eminent scientists, even scientists such as Stephen Hawking, have said that the long-term future of humanity lies off the planet. So what does the dictionary say that science is? It says that, well, this is from the Concise Oxford English Dictionary, and considering this is meant to be a concise dictionary, it's pretty long. It says that it's the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. So it says it's something that you think about, that you use your brain on. It says that it's practical, something that you do with your hands, that it's systematic, that there's an underlying method, and that the idea is to try and figure out what is happening in the natural world, in the physical and natural world, and that we're going to do this by carrying out observations and experiments. So it's quite a long-winded sort of statement there, but it says something that we think about, something that we do. There's a systematic method behind it. It's aimed at figuring out how the world works, and observation and experiment are key. So going to a good American dictionary, perhaps something a little bit more to the point might come from this. It says that in the Merriam-Webster dictionary that science is knowledge or a system of knowledge covering general truths or the operations of general laws, especially as obtained and tested through scientific method. So we're going to figure out how the world works, and the way that we're going to do it is through using this thing called the scientific method. So the question, is, do we really have any more understanding of what science is at this point? So after consulting both of these dictionaries, I basically gave up, and I've been a scientist for a long time. I came up with my own definition. So what I say that science is an approach to studying the universe. We're going to make an assumption that the universe obeys laws of natural origin, that is, there's some underlying structure to the way our world works, and scientists, their job is to identify what these rules are, and the tool that we're going to use to do that is the scientific method. So the question then becomes, what is the scientific method? And so the scientific method is a sort of idealized pathway for solving problems, for figuring out what the general rules are by which our world operates. So it commences with taking some observations. These observations are then used to form hypotheses to explain our observations, but these are very special hypotheses in that they have to be testable. You have to come up with a hypothesis that you can test. So you then design experiments to test your hypotheses, and if you're lucky, your experimental results agree, are consistent with your hypotheses, and you can move on. If they are not, then you need to revise your hypothesis. And this process continues until you have agreement between your hypotheses and your experiments. So a few things about the scientific method. When we make observations, we try and keep a track of the conditions under which the observations are made. So we might do things as to note the weather, what the temperature is, what the atmospheric pressure is. And when we design experiments, we try and keep our experiments simple so that only one thing is changing and that everything else is constant. And then that way we don't get confused as to why we are seeing what we are seeing. So when we have a hypothesis and a series of experiments that agree with it, we can move on to the next stage. And the next stage is to formulate a model that explains the results of lots of experiments and is able to predict the results of experiments that we are yet to perform. So we use our model to make a series of predictions, and then we test our model by collecting data and seeing if there's agreement between our predictions and our data that we've collected. If they agree, we are done and our theory remains intact. If our observations disagree with our predictions, then we're going to need to revise our model. Any models that we make should be very simple. They should avoid unnecessary complexity. So the output of the scientific method is here. If we are successful, we will generate a theory that is able to explain the results of any experiments we perform and predict the results accurately, correctly of experiments that we are yet to perform. So we've defined this term here. So we said that chemistry was the scientific study of matter and its transformations. So what is matter? Well, matter is the physical material of the universe. It's the stuff the universe is made of. Okay? A more formal definition could be that anything that occupies space and has mass is matter. Occupies space and has mass. It takes up a certain volume and has a certain mass. If it has those two properties, then it's matter. If it doesn't, then it's not matter. Energy is not matter because it doesn't have mass. Heat is not matter because it doesn't have mass. Empty space is not matter because it doesn't have mass. So mass is the quantity that describes the amount of matter in an object, and the mass of an object is constant at every place in the universe. We'll come back to this in a moment. We measure the mass of an object using a device called a balance. So often mass and weight gets confused. Mass is constant anywhere in the universe and it describes the amount of matter in an object. However, the weight of an object describes the force of gravity acting on it, and it varies with location. For example, you weigh less on the moon or in empty space than you do on the Earth. However, your mass, the amount of matter that you are composed of, remains constant in each of those three places. So matter commonly exists in one of three states: solid, liquid, and gas. And water is an interesting substance because on our planet it commonly exists in all three phases. So an interesting question to ponder is, how is temperature related to the phase of a substance? And as we increase the temperature, we increase the likelihood that the substance will be in the gaseous phase or in the liquid phase. And as we decrease the temperature, we increase the likelihood that a substance will be found in either the liquid phase or the solid phase. How is pressure related to the phase of a substance? Similarly, as we increase the pressure on a substance, it tends to favor the more dense phase, i.e. the liquid or the solid phase, over the gaseous phase. So gases are characterized by the fact that their shape adapts to that of the container and that they fill whatever container they are placed in, i.e. that is, they have a variable volume. So is the density of a gas fixed? It isn't, because gases have variable volume. The volume depends upon the size of the container. So a larger container, the gas will occupy a greater volume, and so it will have a smaller density. Can gases be readily compressed? They can, because there are lots of spaces between the particles in a gas, and so therefore they are readily compressed. In liquids, the particles are much closer to each other than in gases. As a consequence, the density of liquids is much greater than that of gases. That is, a given volume of a liquid will weigh much more than the same volume of a gas. And you can demonstrate this to yourself by considering a water balloon versus a balloon that is filled with air. The water balloon will have a much greater mass than the equivalently sized balloon full of air. Liquids adapt to the shape of the container into which they are placed. So whatever the shape of this container is that we pour the liquid in, the liquid will adapt to it. However, it won't fill it, because unlike gases, liquids have a fixed volume. So the shape of our measuring cup will alter the shape of the liquid, but we will always measure the same volume for a given sample of liquid. So can liquids be readily compressed? Well, you can probably see from this diagram that it's being drawn here, there's not a lot of space between the particles in a liquid, and so they aren't readily compressed. What does that mean? Well, that means that a liquid can be used to push something because it doesn't get compressed. And so that's the principle by which hydraulics work. So in our cars, we have hydraulics lines which can be used to push the brake pads, and the liquid works quite well at transmitting the force because it isn't easily compressed. However, if you get gas into your brake lines, then you're going to have trouble, because when you hit the pedal, the gas will compress as opposed to pushing on the brake pads, and your brakes will feel really spongy and they may not be effective. So is the density of a liquid fixed? Well, yeah, because you really can't compress it anymore. You know, it's got a fixed volume, so its density will be fixed. Okay, so liquids have fixed volume, fixed density, and they are not readily compressed. However, they do adapt to the shape of the container in which they are placed. Unlike gases, solids have fixed shape and volume. That is, the shape of a solid is independent upon the shape of a container, and solids do not fill the container in which they are placed. In solids, the particles are close together, so they have very high density. Can solids be readily compressed? No, there's no space between the particles, so there's no more compression that can take place. Okay, and this is useful as well, because similar to a liquid, we can use one solid to push another solid. And if you ever poked something with a stick to make it move, that's exactly what you were doing. If the solid compressed, you would never be able to move an object by pushing on it with another one. Okay, so we've defined two of these words in our definition of chemistry: the scientific study of matter and its properties and transformations. So what do we mean by properties? Well, two types of properties distinguish different kinds of matters. We have chemical properties and we have physical properties. And physical properties are those that can be observed without changing or trying to change the composition of the sample. So, can anyone think of any physical properties? Well, examples include the color of a substance, whether it's a gas, liquid, or solid, how hard it is, how easily it's scratched, melting point, how high you have to heat it for the solid to become liquid, or boiling point, the temperature at which the liquid becomes a gas, luster, whether it is shiny or dull, the shape, if it's a solid, does it have characteristic shape of its crystals, the size of its crystals, solubility, will it dissolve in water, won't it dissolve in water, and its density. All of these things are physical properties. And of course, mass, we can weigh an object without in any way attempting to change it. Alright, so we're going to stop there, and this will conclude part 1 of this lecture, and we're going to work on some problems from the book now. Okay.